रोशनी रोशनी उम्मीद है तामीर।
Bismillahirrahmanirrahim. Assalamu alaikum. Good morning and welcome to all my grade 10 students. Hope so that all of you are doing well. Dear students, chemistry of grade 9 and grade 10 books have total 16 units and we have studied 8 units in grade 9 and inshallah 8 units will be studied in grade 10. So today we are going to start our new chapter of chemistry, unit number 9, chemical equilibrium. Unit number 9, chemical equilibrium. Equilibrium means equality of distribution. Dear students, in this unit we will learn how and why a chemical system attains equilibrium, and we will also study the characteristics of equilibrium. What happens to a system at equilibrium when a change is imposed on the system, when a change is collected on the system? In particular, we will discuss how to calculate the concentration, how to calculate the amount of reactants and products present for a given system at equilibrium. Our today's topic, reversible reaction and dynamic equilibrium, is on page number 3. Dear students, whenever a chemical change occurs, chemical reaction take place. Due to changes of chemicals, chemical reaction take place, and in a chemical reaction, the substances that combine in chemical reaction, whenever the substances are exposed to combine, whenever the substances are exposed for reactions, are called reactants, and the substances formed are called products. And the substances which are formed as a result are called products. For example, hydrogen and nitrogen, they are reactants. Whenever hydrogen and nitrogen react, so they form ammonia. Ammonia is a product because it forms as a result, because it is a new substance which form by the reaction of hydrogen and nitrogen. Hydrogen and nitrogen are reactants while ammonia is product. Reversible reaction. Reversible reactions are a number of reactions in which the products do not recombine. Mean again. In which the products do not combine again to form the reactants. Such reactions are known as irreversible reactions. These reactions means irreversible reaction whenever once it completed, so it can't be reversed easily. Once the reactions completed, so it can't be reversed easily. In these reactions, the reactants and products are separated by putting a single arrow. The reactants and product in such reaction are separated by putting a single arrow, which is directed, which is from reactants towards the products. For example, when magnesium reacts with excess of hydrochloric acid, excess mean huge. So the reaction stops when all the magnesium is used up, when all the magnesium is finished. The products cannot be converted back to the reactants because it is reversible reaction, and this reaction is an example of irreversible reaction. Now, reversible reaction, besides irreversible reactions, there are also a number of reactions in which the products can react again to form the reactants. Reactions in which the products again react to form the reactants. Such reactions are known as reversible reaction. These reactions means these reversible reactions never achieve completion. These reactions can be easily reversed. In these reactions, the reactants and products are separated by putting a double half-headed arrow between the reactants and products. Irreversible reactions are separated by putting a single arrow, while reversible reactions are separated by putting a double half-headed arrow between the products and reactants. This arrow shows that the reaction can move in both forward and reverse direction depending upon the conditions. My dears, here I have example for you. When mercury oxide is heated in a closed test tube, from which neither the mercury nor the oxygen can escape. Escape means bahir nikalna. So it decomposes, it breaks down and produces mercury and oxygen, because mercury oxygen form from the combination of mercury and oxygen. Mercury and oxygen can combine again to form mercury oxide again, because it is a reversible reaction and it can form again. Thus, both forward and reverse reaction can proceed, can move onward at the same time, and equilibrium is achieved. Thus, at equilibrium, mercury and oxygen will react to form mercury oxide at the same rate at which mercury oxide decomposes into mercury and oxygen. When mercury oxide splits into mercury and oxygen. At this point, a state of dynamic equilibrium has been reached between two chemical reactions, and both reactions continue, but there is no net change, but there is no final change in the composition of the system. Dear students, read the topic thoroughly and then make 10 MCQs from it and write it on your rough notebook. Stay safe, stay blessed, take care, and Khuda Hafiz.